Let's continue our discussion on feature transformation. By the end of this video, you will be able to explain and perform binning. Binning is the process of aggregating data points in different categories to reduce the redundancy. This procedure can be implemented on both the numerical and the categorical columns. Binning not only helps in reducing the redundancy of the independent variables, it also helps in carrying out one-hot encoding or creating the dummy variables. In binning, we will look at the following: binning of categorical variables, binning of sparse categories, binning of continuous variables. We saw binning of categorical variables when we binned zip codes into groups in previous module. In case you have forgotten what we did and why, it is a good time to go and revisit that topic again. Next, let's look at binning of sparse categories. Sparse categories are the ones which occur for a negligible or few number of times as compared to the size of datasets. In this case, we simply bin the categories which are sparse in nature. For this, let's open the Jupyter Notebook and look at the column Condition of the House. The column Condition of the House contains 5 unique values. But when we print the frequency of occurrence of these unique values, we can clearly see that bad and okay have occurred for a very few number of times. It looks like a good choice to bin them. But before we do that, let's have a look at the bar plot of the condition of the house and the corresponding mean sale price. For this, we simply calculate the mean of the houses with respect to the condition of the house. Then, we plot the bar graph for different condition of the house and their respective mean sale price. From the plot, we can clearly infer that average sale price for bad and okay categories are quite similar, and hence having these two categories is actually redundant. We can also see that the conditions fair and good are very similar in terms of their average sales price. As a result, we can reduce the number of classes to 3 by the process of binning. For this, we start by defining a mapping. In this mapping, we rename fair as good and bad as okay. Then we transform the condition of the house using the pandas.map function and passing the mapping that we defined moments ago. Now, we simply repeat the procedure of calculation of mean corresponding to the condition of the house and plotting a bar plot. In the output, we can clearly see that we are now left with only 3 categories or levels under the condition of the house, which actually helps. Now let's see how to bin a continuous variable. For this, we will be working with the age of the house column. We can clearly see that there are 116 unique entries in the age of the house column, and the maximum and the minimum values are 118 and 3 respectively. Now I want you to sit back and think. A house which is 40 years old and another house which is 42 years old, do you think there will be any substantial difference between the selling price of the two, given that all the other features are exactly same? The answer is no. A 40-year-old house and a 42-year-old house will have negligible or no difference between the selling price. To reduce this redundancy, we can use the concept of binning. We can follow any convention to bin the values in age of house column. For the sake of simplicity and to demonstrate implementation, we will perform binning as follows. If age is less than 10, the house is new. If age is greater than 10 but less than 50, the house is old. Else the house is very old. So let's try this in Python. We define the same logic of binning using the condition statement as we have just discussed. Next, we perform binning using the pandas.map function and pass the age of the house function as parameter. On printing the unique values, we can clearly see that we now have 3 unique values which can now be converted into dummy variables as per our requirement. Please note that we have implemented binning on the age of house variable for demonstration purpose only. It is not always advisable to bin a continuous variable since it results in loss of information. For example, there may be indeed a difference between a 1-year-old house and a 9-year-old house, but now, due to binning, both of them are being tagged the same. Binning a continuous variable also results in an increase of the dimensionality of the dataset. For example, age of house, which was a continuous variable, due to binning has become a categorical variable with 3 levels of categories, which on dummy encoding would result in 2 variables. So you should carefully consider your reasons before binning a continuous variable. Now that we have covered the essentials of feature transformation, we will shift our focus to feature generation in the next tutorial. Stay tuned.